Okay, geometry. Just as a reminder, we are skipping over section 2.6 and going straight to 2.7. We will go back to 2.6. We'll do that Monday, Tuesday of next week, but that's just kind of a section that's easier for me to teach while I'm there, because we'll get the blocks out and you'll have to be like drawing and doing all sorts of things in section 2.6. So this one is precision and accuracy though. So we're going to learn what the difference between those two are, but here is the homework assignment for this section. 133, 2 through 16 evens. Okay, so here we go. A lot of people, this is going to not take very long to go through precision and accuracy. We got new textbooks last year, and the books before this, precision and accuracy was actually kind of a longer section, and they had us calculate what's called relative error and absolute error. And they don't have us do that this time. Relative error has to do with precision. Absolute error has to do with accuracy. And absolute error is kind of a tricky formula thing that you do. But now they're just having us do approximate error, which is super easy. So it doesn't go near into depth as what it used to be. So this is going to be kind of a quick, easy thing. But here's what I'm going to say about precision and accuracy. A lot of people use the terms precision and accuracy interchangeably. They're like, oh yeah, that was pretty precise, like that was pretty accurate, right? And they don't really know the difference between the two. They just think that they mean the same thing. And they kind of do to an extent, but there is a huge difference, okay? Here's what I will say about precision. Precision, so circle this word or underline this word. Precision means consistent. Okay, consistent. So like when you're serving the ball over the net, right, in volleyball, you're consistent because you do it the same every time, right? Accuracy means good. So if we go back to our serving example, you could be consistently good or you could be consistently bad, right? Like if I'm consistently serving the ball in the net, I'm precise, but I am not accurate, right? And vice versa, like I can be good, like I can be a good volleyball player, but not necessarily consistent with my serve, right? Like the majority of the time that I do serve it over, it's really good, but like every fifth one, I'm going to serve in the net or whatever. Like I'm not terribly consistent, right? So those two don't necessarily mean exactly the same thing. And a lot of people think that they do. They just use them interchangeably, but there is a pretty big difference, okay? And they're going to use, I like this target right here. Look at this picture to represent the difference between precision and accuracy. So here I have, down here, notice that all of these little dots where I've shot the target are right close together. Okay, that means consistent. So it is consistent, which means it's precise, and accurate means it's good. They're all in the middle of the target and they're all right together. So good, consistent, it is accurate, and it's precise, okay? Here we have accurate. They're all pretty good shots, right? Like they're all kind of in the center. None of them are all the way out here, right? They're all pretty good, but they're not very consistent because they're like kind of spread apart within that little area. So not real consistent. So maybe an example of this would be like, yeah, I can get the ball over the net every time, but I'm not serving to the same spot every time. I'm serving to each one of the 6 serving positions, whatever. I don't know, maybe there's more than 6 serving positions nowadays, but the 6 spots on the court, I'm serving over the net every time, but I'm not serving to the same person every time, right? And I'm not doing it on purpose either. So not consistent, but I'm still pretty good, right? This one is precise, so this is consistent, but I'm consistently bad, right? Like I'm not in the same spot. So consistent, but not good. Okay. So I'm consistently serving the ball in the net. That's this type of thing. Okay. And this is not accurate or precise. I'm not good, and I'm not consistent either. Right? Not good, not consistent. All over the place. So this person has a real lot of work to do. Okay. So that's just kind of like I like this target to kind of show you know, the difference between the two, and how that works. They're going to have some pictures down below here. Yep, right here. They want us to identify which one is which, okay? So out of these 4 pictures, which one is accurate, not precise, precise, not accurate, accurate and precise, or not accurate and not precise, okay? So I'm just going to do A and P. This one is pretty dang good. This is like the best picture out of all of them. So he is precise and accurate. He is good. Precise meaning consistent, and I'm consistently right around the mark. This is horseshoes, by the way. Has anybody not played this? Do you guys know what I'm talking about here? Like horseshoes, right? Okay, you throw them at the stake and you try to get it wrapped around the stake. Anyway, okay, this one, they're all kind of grouped together, which means I'm consistent. I am precise, but I am not accurate, right? Because they're not around the stake. They're in the same spot, that's consistent, but they're not accurate. They're not good, right? Here I'm pretty good, like they're all around. This is accurate, but not precise, because they're not all very like in the same center area, right? There's a little bit of precision that has to come with accuracy, right? But for the most part, they're not like all right close together. We're not hitting the same horseshoes, like they're not stacked up on top of each other. That's what precision would look like. And this one's neither. Not accurate and not precise. They're just all over the place. That's me playing horseshoes right here. That's really bad. Okay, there you go. Let's talk about these two down below here. This is just the check, but what are these two? Okay, this one looks pretty close together, right? They're precise, but they're not in the hole, right? They're not accurate. I'm not scoring any points there on that cornhole board. They're not in the center, right? They're kind of around the same area. This one, they're kind of all spread apart, which means not consistent or not precise, and they're not accurate either because none of them are in the hole. Okay, so that type of thing going on there for my cornhole board. All right. Next thing, approximate error. This is super easy concept, but basically you take the actual measurement of what it should be, and then what my measurement is. Okay, so what the measurement should be and what my measurement is, and then I take the absolute value of that, and they call that ED. That's the estimated error, or no, EA. Error approximate. There we go. Estimated error approximate. All right. A student weighs a 10-gram precision mass on 3 different scales. So we know that like mass should be 10 grams. Exactly. One of my scales is this guy. One of my scales reads this guy. One of my scales reads this guy, right? So we're looking at like how good are these scales, basically. How accurate are these scales, all right? So I'm going to take the 10, what it should be, minus the 9.86, and I take the absolute value, and that is like 0.14 grams is what it's off by, okay? This one, if I subtract 9.92, what I got versus what it should be, that is 0.08, and this guy is... I'm subtracting 10.3, which is a negative 0.3, but I'm taking the absolute value, so it is off by 0.3. Doesn't necessarily matter that it's overestimating. It is off by 0.3. So which of these scales is the best, right? Which one is the best? The one that's off by the least amount. So the food scale is considered the best one. Oh, wait a second. That is not right. Wrong. 0.08. Ha, I fell into that trap. Lab scale is best. 0.08 is smaller than 0.3. 0.3 is actually the biggest. So this is the best one. This one is the middle one. And this one is the worst one, right? 0.3 is larger than 0.14, right? And that's larger than 0.08. So this is the best scale. The lab scale is going to give me the best measurement. All right? Okay? Yeah, and so that helps you determine how accurate your calculations are. So basically we're saying which one is the most accurate. This is the best accurate. I don't know, I'm not spelling accurate right. Yeah, there's only one R and one T. Okay, so that's the most accurate. okay? This one is the least accurate because it is off by the most amount, okay? All right, there you go. That's example 2. All right, this last one is kind of the hardest concept. So listen up to this one. This is kind of hard to understand. So here we go. Let's do this. Let's say I am measuring, I don't know. Let's say I'm measuring a board, and I measure this board to be 14 inches, right? 14 inches, okay? If I'm measuring it to be 14 inches, there is a difference between 14 inches and 14.0 inches, okay? I will fight you to the grave on this, that 14 is different than 14.0, okay? 14 inches means that I rounded to the nearest inch. So, if I rounded to the nearest inch, this measurement, this board could very well have been anywhere between 13.5 inches and 14.5 inches. If it's above 13.5, you would have rounded that to 14 inches. If it was below 14.5, like let's say 14.3, you would have rounded that to 14 inches, right? It could have very well, my measurement could have very well been between 13.5 and 14.5 inches, right? On the low end is 13.5, on the high end is 14.5, right? Okay. If I say he's 14.0 inches, okay, here's where my 14.0 is, right? I know that 14, let's say I did 14.3. 14.3 is not going to round down to 14.0, right? 14.0, the next increment of measurement would be 14.1. This increment would be 13.9. So in that case, right, because I'm rounding to the nearest like one decimal number. So the next decimal would be 0.1, the lower decimal would be 0.9. So in that case, it would be anywhere between 13.95 and 14.05. So my measurement is now more precise. I'm a closer increment of measurement because now I know for sure that my measurement has to be between 13.95 and 14.05. This is a narrower window, a more consistent, more precise window than this is, right? This gives me more precision, more consistent. So there is a huge difference between 14.0 and 14 inches. Here I know we rounded to the nearest inch, okay? Otherwise you would have said 0.0. If you say 0.0, I know you rounded to the nearest, like, one decimal place, right? Whatever, and maybe this isn't in inches, maybe this is in, I don't know, feet or in centimeters or whatever, right? But if you have just one decimal, like if it's just 14, that means I could be anywhere between 13.5 and 14.5 versus if it's 14.0, I'm anywhere between 13.95 and 14.05. Okay, let's see another example of that. So here we have this going on. Calculate with rounded measurements. All right, so we have something that is measured at 10 foot by 8 foot. Okay, so 10 foot wide, 8 foot long, right? Or 8 foot high, right? And this is a piece of carpet for somebody's bedroom. All right, if this is happening, I know that we've rounded to the nearest foot, right? Like 8 is rounded to the nearest foot, okay? If I have 8 here, right, and I'm measuring things, my next increment down was 7, and my next increment up would be 9. So if this was 7.1, he's going to round to 7, right? But if it's anything larger than 7.5, it's going to round to 8. And if it's anything lower than 8.5, it's going to round to 8, right? So this dimension right here of carpet could have been anywhere between 7.5 and 8.5, right? Like this measurement right here, let's call it X, whatever. Could have been anywhere between 7.5 and 8.5. And you're like, well, what if it was 8 exactly? Then they would have said 8.0, right? If it was 8 feet exactly, they would have put that extra decimal place on there and said 8 foot exactly. So I can't assume that it was 8 foot exactly when they didn't put that 0.0 on there. So the only assumption I can make is that it was somewhere between 7.5 and 8.5. This guy would have been, okay, if I measured it to 10, 9, and 11, he would have been anywhere between 9.5 and 10.5. this dimension right here was anywhere between 9.5 and 10.5. Now, I understand that if it's 9.5, it rounds to 10, but if it's 10.5, it rounds to 11. That's why I say not equal to right here. Like, technically, it should go like this, right? Equal to if it's 9.5, whatever. I'm not going to get too worried about these little symbols here. But anywhere between 9.5 and 10.5. This is anywhere between 7.5 and 8.5. Okay, let's do this. He wants the dimensions of his bedroom and rounded to the nearest foot. The carpet he chooses is $2.63 per square foot. Okay, they are asking me, what is the possible range for how much carpet it will cost for his bedroom? Okay, so I know that if my actual length is 10, if they rounded it to 10, that means it's anywhere between 9.5 and 10.5. If my width was 8, that means anywhere between 7.5 and 8.5. Okay, now when we're finding area, we're doing length times width, or base times height, right? At the bare minimum, my minimum length is 9.5 and my minimum width is 7.5. So if I multiply my bare minimum measurements together, 9.5 times 7.5, I get 71.25. Oh, sister, what's the matter? Here. You want that? Come here. Come here. Okay. Okay. Here. Here. Say, Mommy's talking too loud. There we go. Okay, so at the bare minimum, I have a 9.5 by 7.5, which give me 71.25. That is the minimum amount it could be, right? The smallest dimensions I have are those two. And if I multiply them together, it's 71.25. That is the minimum that this carpet could be, okay? Maximum, he is 10.5 by 8.5, and if I do that, he's 89.25, right? So this is the maximum amount, my square footage that my carpet could be, right? So if I go $2.63 per square foot, right? I'm going to take each one of those measurements, 71.25, and I'm going to multiply by, what was it, $2.63? 263, and I get 187.39. At maximum, I have 89.25, and I multiply that by 263, and I get 234.74, right? Those are my two measurements, right? So we know that the cost of my carpet is this much at the least and this much at the most, right? Now that's a pretty huge window. That's a window of like $50. Like, what if I want that to be closer, right? Like, what if I want that window in closer? Well, what I'm going to do is, if I want to know more precise than that, what the measurement is actually, or what the cost is actually going to be, I'm not going to measure to the nearest foot. I'm going to measure to the nearest, like, 0.1 feet or the nearest couple inches, right? So what they've done here instead is they've said, okay, he checks the dimensions of the room and measures it to be 9.8 by 8.2. All right, so if it's 9.8, then the increment right below that would be 9.7. The increment right above that would be 9.9, right? So I know that 9.8 is somewhere between 9.75 at the minimum and 9.85 at the maximum, right? So 9.75 by 9.85, all right? 8.2 feet, 8.2 is here. The increment right below that would be 8.1. The increment right above that would be 8.3. At the bare minimum, this will be 8.15. At the maximum, this will be 8.25, right? That's what my minimum and maximum are, right? So what we have going on here is, I'm going to need a calculator. So we have the minimum is 9.75 by 9.85, and I multiply those together and I get this dimension. Wait a second, that was not right. Blah, 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 blah. Blah, 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 blah. 9.75 times 8.15. There we go. Okay, these are my minimum measurements. My maximum measurements are 9.85 by 8.25. Or, now I need a calculator. Un momento, por favor. I gotta go find a calculator. Oh, there's my calculator. All right. we have 9.85 by 8.25. And that is 81.2625 square foot. This is a lot closer together of numbers, right? We're talking 79 in comparison to 81. That's a little bit more precise for our square footage, all right? So at the very least, my square footage is 79.4625, and if I multiply that by my $2.63 per square foot, give me a second, 4625 times 263, we got, oh, they gave it to us, that was silly, $208.99 versus 81.2625 times $2.63, and that is $213.72. Look at the difference between those two. That gives me a lot better or more accurate of a, like, I know how much money I'm going to spend when I walk into the store. Versus here, like, I was like a $50 window. I had no idea what they were going to throw at me for an amount when I walk into the store, right? For buying this carpet. Here, I'm within $5, right? So look at the difference just rounding to one more decimal place on my feet results in, okay? So I know at the least it costs this much, at the most it costs that much. And that gives me way better, right? When the measurements were rounded to the nearest foot, the range was more than $45 versus now the range is within $5. I can know how much my carpet is going to cost, okay? All right, that last example was a bit long, but hopefully that gives you an idea, especially when it comes to, that is like almost the same as example 6. Okay, so look for example 3 when you're doing when you're doing problem number 6, all right, and try to go through those. 2 through 16 evens, use the rest of the time in class to finish those, and I will see you. Have a good, nice, long weekend. I will see you on Monday.